Welcome back to the FNS Development Training Series. In the last video, we focused on API routes, especially the GET systems endpoint, and how your backend uses the FNS SDK to call the ProCaaSo framework. Now, we're going to focus on what happens after your backend retrieves data, how your FNS stores it in the database, and how it can automatically store live events by subscribing to updates in the fns.py file. By the end of this video, you will understand how the dbfunctions.py file opens database connections and writes to your migration tables, store systems in the systems table that we created in the migrations video, briefly understand what the other event storage functions do, and understand how live events flow from ProCaaSo to the FNS by subscribing to attributes. The dbfunctions.py file is your backend's database layer. This file is responsible for opening database connections through the FNS SDK, writing records into the tables that you created in your migrations folder, updating existing records safely, and accessing stored values using your API routes. Database access is handled through the FNS SDK. Anytime you see the getDB connection function, that line is opening a connection to the ProCaaSo database for your FNS. The pattern that you want to follow is simple. Open the connection, do your database work, commit if you made changes, and close the connection. That way, connections never get stuck open. The store retrieved systems function connects directly to the get systems endpoint that we went over in the previous video, and it writes to the systems table that you created in your migrations video. Here's what it does. First, it extracts system names. The ProCaaSo framework returns system data as a list of dictionaries, and this function filters that data down to just its name. Then we open a database connection using the FNS SDK getDatabase connection function. Then we execute our database logic. Here we are inserting the system names that we extracted. And lastly, we commit the changes and close the connection. Now that the systems are stored, the next job of your backend is to store live event updates. These next functions support event storage. The upsert event function inserts event data into the events table or updates an existing row if one already exists. It uses an on-conflict rule based on a system ID and root, and this means that if a new update arrives for the same system and root, the row updates. Next, we have the update latest event function. This function keeps the latest events table updated. It also uses an on-conflict system ID rule, so each system keeps one latest row that gets overwritten as new updates arrive. Then we have the save event function. This is the function that your subscriber calls when an event arrives. It opens a database connection, creates a clean event data payload, stores the event state as JSON using JSON dumps, calls the upsert event function to store and update the event, calls the update latest event function to update the most recent snapshot, and commits and closes the connection. Lastly, we have the getLatestEvents function. This function supports the getLatestEvents API endpoint in our routerfunctions.py file. It queries the latest events table, converts rows into dictionaries, and returns clean JSON back to the backend root. This is how your UI can pull current state values quickly. Now that we understand the database functions, let's connect that to the fns.py file. The save event function is not called manually by your UI. It's called automatically when your FNS receives a subscribed event. So let's go over the react and save event function. This is your callback function. Whenever a subscribed event is received, this function runs. It logs the event, validates that the event contains state data, parses the incoming JSON string, and calls the save event function to store it. This is the bridge between real-time events coming from the ProCaaSo framework and rows being written into your database. Next, we have the setup subscriber function. This function defines what you want to listen to, then defines an attribute using the root, instrument, and attribute from your system definition. So for this example, we'll use the distance sensor component, aka the root, the sensor instrument, and the state attribute. Then it subscribes and attaches your callback function. So every time that the distance sensor state attribute updates to ProCaaSo, your backend retrieves it and stores it. Within this function, you can subscribe and listen to as many attributes as you want. So where does a subscriber get attached? In the app factory function, you'll see this line, create app, set up subscriber. This is the moment that the subscriber becomes active, so now your FNS is doing two things at the same time, serving API routes and listening for live updates and saving them automatically. And that's the database layer and event storage flow. In the next video, we'll walk through the file management functions provided by the FNS SDK, including how to list, upload, download, and delete files through your backend.